The United States can use a combat laser from the air, Death Beam. Humanity has moved into the era of hypersonic weapons, with the Russian and Chinese armies already having missiles flying at speeds of 5 to 20 Mach, and the United States desperately trying to catch up. At the same time, these countries are constantly looking for protection from these weapons, and laser weapons are considered one of the most promising options for defense. In this article, we'll look at the development of laser weapons for the U.S. Air Force and analyze the realism of some military officials' statements that these weapons will already be in service and that Star Wars will become a reality. However, as we'll see, the situation is not so simple and optimistic. First, let's briefly look at the reasons why laser weapons are considered promising. Hypersonic weapons are a combination of extreme speed, up to Mach 5 or 3,800 miles per hour, and active maneuvering, a quality that makes it extremely effective on the battlefield. For example, a Russian Kinzhal missile can fly from Times Square to the Statue of Liberty in less than 10 seconds. At the same time, Minuteman warheads, which have been part of the U.S. arsenal since the 1960s, also fly at hypersonic speeds, but they do not maneuver and follow a predictable ballistic trajectory. On the other hand, a hypersonic missile that's actively maneuvering makes it almost impossible to accurately calculate its trajectory. However, for a laser beam, all these maneuvers and 10 to 20 passes are not a problem. It doesn't need to calculate the predicted angles to hit the target, it's simply enough to point the laser at the target and press the fire button. At 671,080,888 miles per hour, at least 17,000 times the speed of a hypersonic rocket, the laser beam will hit the target in a millionth of a second. The second advantage of laser weapons is the low cost of a shot, which is comparable to the price of a cup of coffee. Compared to the cost of an anti-aircraft missile, which costs almost $1 million or more. Therefore, a laser can shoot down not only expensive hypersonic missiles, but also cheap drones costing hundreds of dollars. This is one of the reasons why laser weapons are being actively developed at present. Earlier we talked about American developments for the Navy, and now we look at what lasers are planned to be installed on combat aircraft. As in the case of the U.S. Navy, combat lasers for aviation are being developed under several programs simultaneously. In 2019, Lockheed Martin installed the Airborne High Energy Laser prototype on the AC-130J Ghost Rider aircraft. The AC-130 is a direct-fire laser combat carrier that's been converted from the C-130 Hercules military transport aircraft. Given the specifics of the carrier aircraft, it can be assumed that the laser system will be large and heavy and will be mounted in the lower part of the aircraft, possibly with a retractable mechanism. Layout solutions similar to these have already been successfully tested on older models. It's also worth noting that lasers have been reported to be used on transport aircraft before. In its current form, the AC-130J Ghost Rider can provide effective fire support and attack a variety of ground targets at long range. For example, the aircraft can effectively use artillery within a radius of several kilometers, and Hellfire missiles can fly at a distance of 10 to 11 kilometers. The SDB and SDB-2 bombs have a claimed range of up to 110 kilometers when used against a stationary target or 72 kilometers against a moving target. It's currently unknown how far the new laser can hit targets. However, the Pentagon says that after the AHEL laser is installed, the aircraft will gain new capabilities. At full power, the laser can be a useful complement or replacement for guns in certain situations. Using the laser, it'll be possible to destroy or disable various targets and objects. However, there's no detailed information on these new capabilities yet. One of the scenarios for using an AC-130J with a high-energy laser, described by former AFSOC Commander Lieutenant General Brad Webb, is to locate and destroy electrical transformers, communications equipment, and drones at airfield parking lots. The destruction of hypersonic missiles is not mentioned, as certain justified reasons for this will be discussed later. As for the power of the AHEL laser, the Lockheed Martin press release does not contain specific information about it. However, the U.S. Special Operations Command reported that the laser will be of the 60 kilowatt class. At the same time, the manufacturer is seeking to increase the system's power to 150 kilowatts, and some sources suggest the AHEL's power is about 100 kilowatts. In 2017, Lockheed Martin successfully tested a new 60-kilowatt combat laser using a technology that reduces power consumption by an average of 50% compared to solid-state lasers. The U.S. Army confirmed the success of the test and adopted the laser. Also in 2017, the U.S. Air Force Research Laboratory signed a contract with Lockheed Martin, Boeing, and Northrop Grumman for the SHIELD, Self-Protect High Energy Laser Demonstrator program, for a total of just over $26 million. Boeing developed the capsule and tethered the system to the aircraft, while Northrop Grumman is responsible for the beam control system that aims the laser at the target and holds it until the target is destroyed. In 2022, the customer received the beam control subsystem. Lockheed Martin focused on reducing the size of its ground-based laser system and solving problems with its cooling on aircraft, and in 5 years managed to reduce the system to 1/6 the size of the Army's and place it in a capsule. It's not known whether the power of the Army laser has been preserved, as the focus was not only on miniaturizing the unit, but also on reducing its power consumption. It's impossible to install a generator used in ground forces on a fighter jet. The Lance prototype was able to shoot down several air-to-ground missiles during ground tests in New Mexico, which demonstrates the success of solving this problem. Plans to install Lance on a specific aircraft have not yet been determined, although the company has conducted its research on a C-130 cargo plane, and promotional images showed the capsule attached to an F-16 fighter jet. In 2019, Boeing tested its laser-free capsule on an F-15 fighter jet. At this time, U.S. Air Force pilots are already learning to use laser weapons in flight simulators to repel attacks in the air. The NGAD project is developing a 6th-generation fighter jet that can be equipped with laser weapons. At the same time, Lockheed Martin was able to reduce its laser for ground forces by 5 times in 5 years, so it can be assumed that in 7 years, laser weapons will already have sufficient weight and size characteristics for use on fighters. But unfortunately, it seems impossible to destroy hypersonic missiles at the moment. This can be explained by the fact that hypersonic missiles have strong thermal protection and can withstand temperatures of up to 2,000 degrees Celsius, which is much higher than the temperature at which laser beams can affect targets. In addition, a very powerful laser is needed to destroy hypersonic missiles, which requires significant energy and technical resources, such as a powerful cooling system and sufficient space for placement. Therefore, if the laser is placed on a ship, these problems are not as critical as for an airplane, where every centimeter of space and gram of weight is of great importance. The second problem is pinpointing the exact location of the target. To destroy it, you need to apply a laser beam to it for several seconds with an accuracy of several millimeters. In addition, the targeting system must take into account the fact that a hypersonic missile is traveling at speeds of over a mile a second or even 2 miles per second. In addition, additional problems may arise, such as absorption of the laser beam by fog or a decrease in energy concentration at a remote distance. The decrease in the effectiveness of laser weapons is proportional to the square of the distance, which means that at a distance of 100 kilometers, the energy of a laser beam will drop 100 times compared to a distance of 10 kilometers, if at this distance it can destroy the missile's body. That's why laser weapons are currently effective only in close combat, and even in the future, they will not be able to detect AIM-120D air-to-air missiles with a range of 180 kilometers. We'll tell you more about what laser weapons will actually be like in our next video soon. So don't forget to subscribe to our channel and give us a thumbs up if you like the video.